Excellent. So let me just. So good morning, everyone. Thank you for the opportunity to spend a little time with you today to describe VMware's Cloudstack integration of its NSX network virtualization platform. My name is Andy Kennedy, and apologies to those of you that are looking at the printed notes. My colleague Somik Behera was actually due to be here today, but due to various issues, he's been unable to make it. But I'm one of the members of the same team within the Networking and Security Business Unit at VMware, and I'm just going to spend the next 30 minutes really walking you through what we would call maybe a 201 session, so a little bit more detailed description of how NSX works in a cloud stack platform, and to just give you an indication of how it's being used with some of our customers. Now, I'm happy to keep this as an interactive session and take questions as we go along. There is a microphone there as well for the benefit of the people who are watching this on the live stream, but of course, if there are questions, I'll happily take them on the floor as well. I do have two things today. One is a presentation, which we can change and we can work around. The second is a very strong Glaswegian Scottish accent. If I go too quickly, please raise your hand and I will slow down and try and clarify on any points. So in terms of VMware's collaboration with Cloudstack and as a partner of our NSX platform, we have been working in the Cloudstack world now since around June of last year, and indeed there was a lot of work up till June of last year. And basically what we did is we collaborated with Schuberg Philis to help develop what was formerly the Nicira network virtualization platform, and to use that to provide the networking services to Cloudstack. And indeed, it's really a collaboration of both Schuberg Philis and Nicira at the time, helped basically derive and deliver all of the capabilities that indeed their cloud is actually running on today. And if you look actually at the Cloudstack website, you'll actually find that there is actually an implementation guide to use the Nicira network virtualization platform with Cloudstack. And we, shout out to Hugo at Schuberg Philis, who has helped greatly in the work in the community to basically build the support to make the correct API calls, etc., to set up networking within Cloudstack using the NVP platform. So just for clarification purposes, I just wanted to touch on a couple of things. The first is that VMware made an acquisition of Nicira last August, and that acquisition now has kind of permeated through the organization, and the formerly Nicira network virtualization platform is now known as VMware NSX. Some of you may have seen NSX announced in the press. NSX is the next release of the MVP platform, and indeed is basically all the same API calls, etc., all permeate through into that platform. So from now until the rest of the remainder of the presentation, I will talk about NSX and not NVP, just for clarification. So then a little bit detail then about what the architecture is and the system components. So the first piece is really the brains of the system, and it's the controller cluster of NSX. And this does two things. The first is it provides a northbound API, and this is effectively the APIs that are called by Cloudstack in order to request networking services that are provisioned programmatically over the top of any existing physical infrastructure. It is also the brains of the system. It retains all of the state and information about what networks exist, which workloads are connected to those networks, and where those networks need to be presented in terms of the hypervisors that are actually connected and presented in that environment. The second thing is what we call the NSX vSwitch, and I want to be very clear, this is actually an OVS-derived vSwitch, and indeed this is the way we support multiple hypervisors. So today we support vSphere natively, but we also support Xen and KVM. And to be clear, actually, VMware and Nicira have actually continued to contribute and develop the Open vSwitch project, and we are one of the lead developers and contributors to those projects. We're also one of the lead developers and contributors to the OpenFlow project as well. So as we continue to add and enhance capabilities, we want to share that with the community, and we definitely encourage that sharing of those developments with the rest of our industry. So on top of the vSwitch, then, we use that effectively as the data plane within the hypervisor on which we actually create the logical networks to which the VMs will actually connect to. And we have this concept of creating logical switches, and these are really arbitrary, logical contexts that are used to provide either layer 2 broadcast domains or layer 3 networks to the virtual machines. So they're effectively the services that we're providing to those VMs. And very importantly, it's very rare, even as a VMware employee, that I ever walk into a data center and find that data center is 100% virtualized. In reality, we find it's normally a mixture, whether it be a service provider that's providing hosting services as well as cloud services, or whether it's a private enterprise that maybe has existing workloads that still reside on dedicated physical infrastructure. We normally find there's a need to provide some form of gateway whereby we can actually bridge the logical networks, so the logical switches that we create to service the virtual workloads, to the physical VLANs that are created in the physical infrastructure. And its ability to provide that gateway to bridge those two entities together allows us to provide seamless connectivity between both the logical space and the physical space. And indeed, even if your network or your environment is 100% virtualized, you will still at some point probably have to talk to the internet or talk to maybe a private MPLS wide area network. If that's the case, again, a gateway is required in order to do that bridging functionality. But the most important point really is with the concept that we're talking about really today is network virtualization. And network virtualization really is around providing all of the networking services that a VM expects, being able to provide that in a programmatic fashion. In order to be able to do that, we need an API, and indeed we have a RESTful API that people like Hugo at Schuberg Philist have used to allow the cloud management platforms to be able to program and request the logical services that we provide. And if we think about what that actually enables us to do, is that from a business perspective, it allows us to get new applications and services to market far more quickly. And indeed, for organizations who have a need for that agility, who have the need to have programmatic control of their infrastructure, then indeed providing the RESTful API, which is extensible, allows you then to provide this form of integration and support. So we then look at the functional system blocks then of NSX, because this is going to help us maybe build the picture about how actually this solution actually operates. So in the data plane, today we support a number of hypervisors, and the data plane effectively is created on x86 using the hypervisor, but in essence it's actually through the virtual switch that lives within that hypervisor. And what we're doing is taking those virtual switches and using them as a packet processing pipeline, which we can remotely program from the second component, which is the controller cluster that we talked about. So for many of you who come from a networking background, for many years we've had this paradigm of a separation of control and forwarding plane. Indeed, that is preserved. And one of the key points is that data should always live within the tenant environment within the data plane. We should not be pushing traffic up into the control plane for forwarding. So the reality is that there's complete separation from a data perspective, from a security perspective, for everything that lives in the data plane is not pushed to the control plane and vice versa. So as you can see, we've got a number of various hypervisors. I would just call it Hyper-V is actually supported using a gateway today. We do have some plans to provide native integration with Hyper-V, but today KVM, XenServer, and vSphere are all natively integrated. And what this basically means is that we have the capability to program the logical services into the virtual switch that lives within that hypervisor, and therefore this allows us to achieve the forwarding capabilities at near line rate performance. And this is very important as we begin to scale up our infrastructures and we have more and more east to west traffic and we're creating higher demands on the networking, we have the ability to enforce and provide line rate performance within those hosts. As we build up the picture then, we have API calls, and the reality is that whilst Cloudstack is a fantastic platform to deliver cloud workloads, there is always the need to be able to provide operational administrative control to both the networking team and to the cloud admins and the DevOps community to be able to interrogate the system and get metrics back on the performance and visibility of how things are actually working. And indeed for that we have a separate component called the NSX Manager that basically allows you to provide a web-based API interface console into the system to basically interrogate it and get metrics back around availability, for troubleshooting purposes, etc. And lastly, the most important point from the conversations today is around the cloud management platform. And really, we can't emphasize enough, the cloud management platform is strategic to your business. And the cloud management platform is the piece that effectively allows you as an end user to consume services from the infrastructure that you in this room are actually providing to those users. So the reality is the user consumes these services from the cloud management platform, and we leverage both existing cloud management capabilities within Cloudstack, but then we also deliver the services from the NSX network virtualization platform and bring the two together. So that's a little overview of some of the key functional system blocks, but then we're going to talk about now some of the architecture. And the first place to spend is really around the management control plane. So if we think about what we have Apache Cloudstack on the top right-hand side of the picture, and we have our hypervisors running on the physical hardware, which are then attached across an existing physical network. And this is quite important because one of the key points here is that for many organizations, we're not necessarily going into a greenfield site. There will be existing infrastructure that's in place that has to be used and might have to coexist with other platforms. If that is the case, we want to be able to overlay this technology on top of any existing hardware vendors' equipment. And indeed, this could be Dell, HP, IBM servers, or Cisco UCS. And indeed, the physical network could come from something like Cisco, Arista, Brocade, maybe Juniper, or somebody else, and have the ability to overlay these network topologies arbitrarily without any dependency on what goes on underlying in this physical infrastructure. So really what we're doing is decoupling ourselves from the physical infrastructure and allowing us to present these services and software. So if we think what happens, the reality is we have our controller cluster which manages the state that lives within those virtual switches. So this is us programming the packet processing pipeline in each one of these hypervisors. And what we do is we make a request to that controller cluster for any network topology. So it could be a multi-tier network, it could have web application and database, it could be a single flat network, it could be any arbitrary network topology that can be then programmed and overlay across this infrastructure. At that point, effectively, the Cloudstack environment is what is actually making the RESTful API call to the controller cluster to make the services. So an example would be, please give me a layer 2 network, please give me a layer 3 network. It could be in a vSphere environment, give me a firewall, give me a load balancer. And indeed, as we begin to spin up the workloads and schedule them onto the various hypervisors, at this point, we then can deploy security policy around those, therefore giving us both L2, L3, plus also the security requirements that fit around the virtual machines as well. And this is important because at this point, we have the ability to control all of this infrastructure remotely through the APIs that we provide to Cloudstack. And as we build up the picture, effectively as we deploy these VMs, we have to connect them. And the way we connect them in the data plane, and we're just going to talk about that in a second, is effectively we build tunnels between the hypervisors. So we talked about the controller cluster. If we then think about the virtual switch, it really just has two main points. The first is it has the ability to be remotely controlled by this controller cluster, but it also has the ability to encapsulate packets. And for those of you that might be familiar with this technology, this is where we begin to introduce the concept of overlay networking. And this encapsulation, we have different types that we support. It could be VXLAN, it could be stateless tunnel transport, it could be GRE, or it could be IPsec. We're not really religious about the specific encapsulation type, but what we want to just emphasize here is we have the ability to perform encapsulation and carry the original Ethernet frames and packets that we get from the VMs in those tunnels that we create using that encapsulation mechanism to be able then to create these arbitrary topologies on top. So if we think about the physical space, therefore, how do we actually get these Ethernet frames and packets that live within the virtual space, how do we get them into the physical domain? So there are two methodologies we can approach. The first is using software, and as part of the NSX platform, we do actually provide a software-based gateway. So it's basically an ISO that you can deploy in any x86 hardware, run it as a VM or run it as an appliance, and it allows you to basically bridge on two ports. So you have one port which effectively connects the tunnels, shown in blue, to the other hypervisor hosts, which carry the encapsulated packets from the VMs that we have above here. And the second port is effectively an 802.1q trunk. So it's a trunk port that effectively allows you then to connect to a physical switch on that trunk port and present the VLANs that are connected to the physical workloads. The benefit here is that you can then write a simple call to basically say, map this logical switch or logical network to this logical VLAN that created in the physical space. So effectively, I can create a layer 2 broadcast domain that connects my VM to a physical database, or to a physical firewall, or physical load balancer, or physical router. And they can all appear from a VM's perspective to be logically adjacent. We also have the ability, and through the support of some of our hardware-based partners, to actually run that software capability in a hardware-based platform. So if we think about an x86 server, there's a limit to how many network interface cards I can actually put in that server. There's also a limit to the performance it can actually push. It can be near line rate 10 gigabit Ethernet, but the reality is if we leverage our existing hardware partners of switches, then you might be able to get, for example, a 1RU 4 to 8 port top of rack switch and have that switch actually perform the same function as the gateway that we just described in software. And this is now the ability that we can remotely control this physical switch from the controller cluster and allow us to provide that capability to bridge the logical VLANs in that switch into the logical networks we create then within Cloudstack. Again, providing that seamless connectivity from a networking perspective between the logical domain and the physical domain. So we drill down a little bit deeper. What about life of a packet? So for all of the network engineers in the room, you may be familiar with these types of presentations where we talk about the life of a packet. And I'm just going to walk you through the process then about how we do this encapsulation, how we build these overlay networks. So the red dot just basically simulates a packet that's generated by a virtual machine. And effectively, the first process is that it's encapsulated. You put in an IP header, you put an Ethernet header on it, and this is just regular networking, same as it would be in the physical space. But at this point, we then wish to apply policies. So we might want to do access control lists, firewalls. We might want to apply some kind of quality of service metrics. We might want to even mark the packet, set the diffserv core point value or type of service byte. So we perform that on ingress. So this is as the packet arrives at the virtual switch. As we then pass it to the physical NIC, we actually have a couple of capabilities. The first is we can then encapsulate the packet. So we can basically put a new header. Now, this actually has an IP address, and this IP address is basically the destination tunnel endpoint of another hypervisor. And the way that it knows what IP address to put on the destination here is the controller cluster has actually programmed this vSwitch to know that effectively if it wishes to reach another virtual machine on another host, then to encapsulate it with the IP address of the physical hypervisor that actually hosts that VM or that workload. Now, this encapsulation is actually offered in a couple of different forms, as we mentioned. So we support things like VXLAN and GRE and IPsec. But there is also another encapsulation called stateless tunnel transport. And effectively what this does is uses a TCP packet format, doesn't use TCP, but just uses the packet format. And that allows us to leverage the TCP segmentation offload capability in the network interface card that lives within that hypervisor. And the benefit of this is that then you remove any of the overhead that's associated with the encapsulation process and actually leverage the interface card to do that for you. And this has some marginal benefits in terms of performance, but it does have some real-world performance gains, and definitely it's one of the reasons why people use this technology to enable them to perform this encapsulation. So as we then progress, the destination lookup's happening, and you can see effectively without having to touch any of this physical hardware, we've then sent this traffic across. So the key point here is that we can actually route this Ethernet frame, because this physical fabric that we're actually connected to could be a layer 3 fabric. It could be routed, it could be a simple leaf spine architecture, it could be a 3-tier access, distribution, and core architecture. But the reality is, even though this is a routed infrastructure, we're still able to connect these two VMs at layer 2 across the top of this network through this overlay concept. Now, as we deliver this Ethernet frame, of course, it's still got a header, it's still got a payload, so we have to remove and de-encapsulate that packet, therefore delivering the original Ethernet frame to the virtual switch. Now, as part of the previous header, you'll notice basically we have this tunnel protocol, whether it be VXLAN or STT, they normally have some form of identifier which basically tells the virtual switch which logical switch or network this traffic is intended to be forwarded to. So as we pass that to the virtual switch, we can then on egress apply more access control lists, quality of service, or firewall functionality to the packet. And ultimately then we deliver the original Ethernet frame to the VM. So you can see how we can build out these logical networks. And of course, these hypervisors could be completely disparate within the data center. You could have a VM in rack number 1, you could have a VM in rack number 100, but you can still have a layer 2 adjacency between those VMs, even though the network that you're connected to is an L3 fabric. So the reality is that as we pass the VM, the actual workload itself has no visibility of the fact that it's actually talking to a virtual network. As far as it's concerned, it's still talking to an existing network that you would see in the physical space. So how does this actually look? Because obviously we've built up this picture, and if we think about the tunnel endpoints, how do we know these tunnel endpoints are reachable, and how do we know that the VMs are actually connected? How do we troubleshoot and monitor this? So what we're going to do is actually jump into effectively the NSX platform, and we're just going to launch a little tool called the Port Connections tool. And actually what it's doing is effectively we're going to pick a logical switch, and we want to just check the connectivity between two virtual machines within Cloudstack. So here we're picking the MAC addresses of two virtual machines, and we want to just make sure that those VMs are reachable. So what we'll find is that as we run the diagnostics, effectively it'll tell me that the VMs are connected. It'll then show me a picture of the physical fabric. So effectively, these are the hypervisor hosts on the left and right-hand side. So these are the physical servers. And it tells me both the unicast, the multicast, and broadcast tunnels, and also the gateway connectivity out to the outside world. So immediately, if there was any problem, these tunnels would go red, and we'd have identification of where the problem lay. Whether it be in the virtual space, it would show up here, or in the physical space down here, it would show down there as a red line. So we have the ability to immediately, from an operational perspective for Cloudstack, to go in and drill down and see what the physical state of the network is. And of course, we can then interrogate the system and provide more metrics around what the UUIDs are, so we can troubleshoot in Cloudstack. We can see what the kind of transport encapsulation types are. We can see whether the STT model is used or VXLAN model is used. So we have the ability to drill down and get visibility of both the physical space and the virtual space. If we take a step back and think, how do you troubleshoot a physical network today? The physical network today has no visibility of the logical VMs. But with this solution, you have the ability then to correlate the two. You can see both worlds, and you can identify where problems lay, whether it's in the physical infrastructure or the virtual infrastructure. And again, it's a very compelling reason why people might look to use NSX as part of a Cloudstack deployment. So we talked a little bit about existing physical workloads and virtual workloads, and really, again, just to highlight the point, so we want to perform that decoupling of the physical and virtual space. So we have an existing physical network, but in this case, maybe we want to use an existing firewall. It could be a Juniper SRX, it could be a Checkpoint, it could be a Cisco ASA, it could be anything. And what we want to be able to do is have our logical VLANs that connect our physical servers, so 1 and 2, and the blue VLAN, and we have servers 3 and 4 in the physical space connected to the orange VLAN, but have them routed via this physical firewall, because maybe we want to do IPS, maybe we want to do some form of really advanced deep packet inspection that the virtual switch and the NSX platform cannot deliver. If that is the case, then what we can do is we can bridge these within the gateway, and indeed from a virtual network perspective, you can see effectively if this was, say, 10.10.10.0 and this was 10.10.11.0, you would have two networks, and of course these VMs and these physical workloads we believe they're actually directly connected on the same network, even though some are virtual workloads, some are physical workloads. But their default gateway would be .1, which is effectively living on the physical firewall, load balancer, or router. So effectively, this could therefore then provide those L3 services or L7 services in the case of IPS or deep packet inspection. So again, it gives you the ability to leverage what you already have, whether it be in the physical domain, or you can use the services within the NSX platform. And there's reasons why you might choose one over the other. Indeed, if you're looking at an F5 load balancer, they do IROs, all these great things that F5 bring. If it's Checkpoint, all the great things they bring. So again, the ability to mix both models is absolutely something we see as very important, particularly in a cloud environment whereby you might already have existing services, or you're dealing with enterprises who have specific requirements and needs for those functions that aren't provided natively within the platform itself. Now, of course, as part of our ecosystem, I just would like to highlight, a couple of our partners. So Arista, Brocade, Cumulus Networks, who you heard mentioned this morning, Dell, HP, and Juniper Networks, all have the ability now to provide these services in those gateways. And indeed, I encourage you to ask those vendors about their plans about when they'll actually provide product to market to actually support this functionality, because we believe that the coupling of the physical world and the virtual world is important, and indeed we are working with those partners, enable them to be programmed remotely by the NSX controller so that you can have a seamless platform to use. So the question is that, this is a DevOps type meetup. So one of the things I was thinking about when I was preparing this presentation is how might you extend the NSX platform to work with Cloudstack. So if we think about an API, how would I consume an API? And maybe I'm not necessarily an API developer, but I want to be able to leverage the API and have code generated for me. I don't want to have to go and create it myself. So in this case, what we're going to do is we're going to just have a look at all the different services we can create. So these are all the API method calls that we can actually use, and there's a huge list of them. But what we're going to do is basically just simply create a logical network. And this is just to give you an example about how this might be achieved and how you might actually interrogate the system. So what we're going to do is just query all of the methods that are available, and we're going to basically create a logical switch. So basically, this is a RESTful API, so we're going to basically do a post method effectively to create this logical switch. So we're going to give the switch a name, call it AK database tier. We're basically going to create what we call a transport zone. So this is effectively which hypervisors we're going to allow this network to be applied to. We'll then basically have a look at the transport types. So you'll see there's a whole list of options in the transport types. You'll pick, for example, GRE might be the default in this case, but you have STT, you could bridge it, you could IPsec, you could various options. And then you can choose the replication method for unknown unicast, broadcast, and multicast traffic. Now at this point, what we're going to actually do is we're going to submit this API request. And when we submit this API request, what you'll actually see is both the JSON formatted request, but also the response that it gets back as well. So you can actually see here, you'll actually see the JSON formatted request that we made, and you'll actually see the response that came back in terms of the content of the body of the API request call. So you can see that just by this point-and-click interface, we can help you extend the actual NSX platform. And if you wish to contribute to the community, you can actually take these capabilities, integrate them with Cloudstack, and create new competitive value for your organization. And of course, you never had to write any code. You could just copy and paste it directly from the system itself. So this is a way we try to make the platform easy to consume. And indeed, the likes of Schuberg Philis and others will use these types of tools to build up the capabilities within the NSX platform. So in terms of availability, whilst we have had shipping product now and production deployments from June of last year, NSX, in terms of its latest incarnation, was generally available as of October the 15th. And in terms of capabilities, we want to focus on the ability to support any application without modification. So we don't want you to have to install any agents, modify the virtual machine, the workload in any way. And we want to basically support that through any cloud management platform. And whilst we're at a Cloudstack conference, you know, absolutely we're fully behind Cloudstack, but also we're a very heavy contributor to OpenStack. We also have VMware products such as vCloud Automation Center and vCloud Director. And we want to be able to support any cloud management platform because those RESTful API calls are agnostic to effectively the CMP. And at which point we will then want to be able to program the NSX platform to deliver a number of services over any hypervisor, whether it be vSphere, whether it be Xen, KVM, or indeed in the future Microsoft Hyper-V. So we have to support logical switching that's decoupling the logical overlay network from the physical infrastructure. So we don't want to have a dependency on the ability to program OpenFlow into physical hardware. We want to completely decouple ourselves from that physical hardware. So we can happily use any networking vendor's equipment, whether it's past, present, or future. We want to be able to create logical routing capabilities, logical firewall, all in the kernel, so we're getting the line rate 10 gigabit performance we associate with an in-kernel virtual switch. We also want to have the ability to support other additional features. Now, some of these are for vSphere only, so things like load balancing and VPN, but we can leverage those that are provided through the Cloudstack native supported services as well. And of course, we talked a little bit about the API, and you saw the API inspector and the mechanisms which we have to actually deploy those services. And lastly, the partner ecosystem is incredibly important to us. And at launch, we announced many networking and security partners who are looking to integrate their products and platforms into NSX. So I mentioned the main networking vendors we're partnering with, but you'll also see a number of security partners that enterprise customers as well as cloud service providers may wish to collaborate with. And of course, one of those in terms of cloud management platform is Cloudstack. And we're proud to be part of the community and contribute. So in terms of the reasons why NSX, why you might be interested, and I'm happy to talk in more detail maybe down at the booth, but the key point here is that if you're deploying a cloud infrastructure, you need to have the ability to have visibility and troubleshooting capabilities into the networking services that you have. And you need to be able to provide them in an easy way to consume way for both the networking team as well as the cloud admins. You also have the ability to have a platform that effectively has been proven in scale and has production experience. And indeed, Schuberg Philis and others are using this technology today and have been for over a year to basically support their stand-up physical and virtual workloads. We have the Layer 2 gateway to allow us to couple both physical and virtual worlds, and we talked a little bit about that today, so the ability to extend not only to support physical workloads, but also the ability to connect to physical routers, firewalls, load balancers, etc. The solution itself is highly available without a single point of failure, and we have the ability to scale out. Indeed, we have production deployments today using this technology that can exceed 100,000 virtual machines. Now, I just want to be very clear, these are production deployments. These are proven for many years, and indeed, these technologies have been deployed in production and are used on a daily basis, and are underpinning some of the biggest cloud service providers' businesses. We have the API inspector, so if you wish to extend the platform, as we showed, it's just a simple point-and-click interface to interrogate the API and get the code in the JSON format that you can then consume. And lastly, we have native multi-platform support, and we are the only vendor being VMware that has access to the VMware kernel, as well as being the main contributor to Open vSwitch, which now is the default Linux bridge, but also is part of Xen and KVM as well. So when you deploy this type of technology, you can be assured of the performance and capabilities we have within the platform, rather than tromboning it maybe through some kind of virtual appliance or VM. So in terms of the key points I just want to leave it with you today is that the architecture itself has been proven. It's fully automated orchestration, so the value you have from Cloudstack itself, you can consume and leverage the networking services now through the NSX platform. It is extensible, and it has the ability to improve the visibility and troubleshooting over what is even possible today with just a physical network infrastructure. And as part of VMware's view is that we have the view of the software-defined data center, where all aspects of the data center are virtualized, whether it be compute, storage, or networking, but also the ability to automate that through software. And we believe fundamentally that that is the correct approach that we see our cloud partners and our enterprise customers adopting in order to be able to deliver these services. And we believe that network virtualization through the NSX platform is effectively what realizes that software defined data center vision. So just to finish off then, if you wish to get some experience and access to this technology, we do have some hands-on labs. VMworld is a massive conference, and we actually build hands-on labs that you can actually use, so that if you wish to play with the technology, you can have access, and it will give you tutorials, but it is a real system, so if you wish to go in and play with the system, you can do whatever you like with it. So those will be there at least till the beginning of December. And also we have a number of YouTube contents. I highly encourage you to look at this one. It's by one of my colleagues, Milind Desai, and he basically gives you an introduction to network virtualization and a use case. So with that, I would like to open the floor to take some questions, but otherwise, I just want to say thank you so much for your patience and interest today, and it's great to have the opportunity to support the community, but happy to take any questions that you may have at this time. Does it use the MVP plugin? Absolutely, yes it does. So with the acquisition of Nicira, the network virtualization platform that Nicira brought, we have rebranded that to NSX. So with 4.0, what was previously MVP is now known as NSX. And indeed, the plugin is exactly the same function calls that get made to that. So great question.
Earlier there is a VCNS plugin for vSphere. VCNS plugin. Is this also merged into this?
So the vCloud Networking and Security Suite exists and continues to exist, and indeed there's many customers who that particular platform will continue to serve, and indeed it's part of the vCloud suite. However, we do have customers that need more advanced networking capabilities, and those customers that have those requirements, maybe they're working in a more kind of competitive marketplace, they're more highly innovative. If they need those additional services, then NSX is the platform that will serve those. But the two are, there's commercial reasons why one might pick one over the other, but from a technical perspective, if you need the more advanced capabilities, then NSX is definitely the way to go.
Can you compare NSX scale with respect to VXLAN already supported by vNetwork distributed switch?
Sorry, could you just repeat that question? Sorry.
We have VXLAN support for distributed switch.
Yep, there is, yeah.
Can you compare the scale-wise? How does NSX pair with that?
So in terms of number of logical switches and logical networks, I mean, obviously the address space is 16 million addresses. From a reality perspective is that we're in the tens of thousands of logical switches today, which is basically just a QA thing. Architecturally, we can scale, way beyond that. But the reality is our customers aren't actually asking for any more. From a virtual distributed switch perspective, NSX now actually provides the multicast-free VXLAN capability within a vSphere environment. The assumption here is most of the audience will be looking for a multi-hypervisor capable solution. And from that perspective, then we're still in the tens of thousands of logical networks, on which we can then run hundreds of thousands of VMs. So the architecture is designed to scale up. Most of the numbers I've just quoted there are more just QA limits, and those are based on what customers have asked for plus a ceiling. If you have more scale needs, I'm sure our account management colleagues will be more than happy to speak to you.
Two more questions. Perhaps another question.
Yes, certainly, of course, yeah. Apologies, but thank you for the question.
Will there be any migration path from existing vCloud networks to this platform?
Yep, so oh, sorry, apologies, yes. So the question was, would there be a migration path for people who are maybe on a vCloud or vSphere infrastructure into this platform? The answer is yes. We will support customers with that plan. We normally can either provide support services or indeed will provide documentation on how to do so.
Will it be online?
Sorry?
Can
Great point. So in terms of how to migrate workloads, we do actually have capabilities to support P2V migrations, but also V2V migrations as well. And indeed, that's one of the use cases for this technology. Now, is it seamless? There are other things you need to think about in terms of storage as well. So it's not just a straightforward plan. But absolutely, this technology is designed to support both those P2V migrations, but also, in your case, the V2V migrations between those environments. And the key point here is not to change the IP address. So what we do, the recommendation is that, and we didn't talk about it, so let me just emphasize one point. The layer 2 gateway today can be packaged as a VM and can be running within your data center, but we also have the ability to provide that as a VM that you can actually give to your service provider, and they can actually deploy it either in a customer's environment or in a remote data center. And if need be, we can actually use IPsec as encapsulation to bring that traffic back. That effectively allows you to extend a layer 2 network from one data center into another data center across either the internet or any MPLS-based L3 VPN. Now, because we have the ability then to extend that L2, effectively what we recommend is that you have maybe your existing workload, and you have your existing or your data center you wish to migrate to. Then what you do is effectively take that workload, get it somehow into the customer and the provider's data center, and then what you do is basically quiesce the service that's back in the original data center, bring up the new workload, but it still has that L2 connectivity and still has access to all of those services and applications and everything else it had to previously without having to change the IP addresses. And I know from a lot of the customers we're working with right now is that re-IPing applications is very, very difficult. Maybe the developer loved his IP address so much he hard-coded it in the app, right? If that's the case, rather than using DNS and all these other things, then that's fine, we can support that. Maybe it's a license restriction, maybe the IP address is actually what the license is tied to for your app or OS, then that's cool as well. And indeed, what you just asked for there is indeed what we're doing with many customers. Good, well, I'm glad to hear that. One more question. Sorry, apologies. Great question. So natively, the API calls are there, but it's not within Cloudstack today. However, if the API calls there, if you wish to do any kind of extensibility, we'd be happy to work with you, I think, on collaboration to improve Cloudstack's capability to support that. For many of our customers, if they are running infrastructure, they tend to want, particularly service providers, they wish to provide their own portal. And the very reason why they wish to do that is because that's effectively their brand. It's also where their competitive differentiation actually appears, right? And the reality is that today, for some customers, they might find it's easier just to write that API call to actually directly from that portal to basically program the L2 gateway function rather than doing the development directly within Cloudstack. But both are appropriate options, and the extensibility and the API inspector we showed previously can be used to develop that capability, but it's not there today.
Let's give a big round of applause for Andy.
Well, thank you very much. Thank you.